Hi, hi, how are you?
Oh, fine, thank you. Svein, how are you?
Good, thank you. Can you just, I was transitioning from somewhere. Can I ask that you just give me a few minutes just to set up? I should be joining you at 17:06, I suppose, 3 minutes from now. I apologize, but I'll be joining you shortly. Thanks.
Right.
All right. Sorry about that. Great. I'm wondering if maybe we should tag this class as starting at 17:10 or 17:20 or something. All right. I hope you're all fine and doing well. I wanted to start off by. Oh, can you see my screen, by the way? Hello, can you see my screen?
Yes, we can see it.
Okay, thanks. It'd be nice if you could respond, right? I just wanted to start off by asking a question. There's a question that we were asked last week, and I don't know if it was last week or something, but I was taken aback, because for me it was more or less like an indication that his understanding of what we are doing, why we're doing what we're doing, was a bit hazy here, right? Just connect that. So I wanted to find out from people, do we all know what we're doing, what we're working towards, why we're doing what we're doing? So Mwa's question was, so can we at this point in time start writing code, right? And I thought, I got concerned because I thought maybe his understanding of oops, sorry, my microphone was off. So I was asking, do we all understand what we are doing and why we are doing what we're doing? Like why we're going through this tedious process of trying to study requirements, and do we all understand why we're doing this? Is there somebody who doesn't understand why we're doing this?
We do have an idea. We might not really understand expectations, but we have an idea of what we're doing.
Yeah, but what do you mean you don't understand the expectations?
Sorry?
What do you mean by saying we may not understand the expectations? This is what, trying to make sure that you understand your expectations, right?
Yeah, my point is, when you say, do you understand? What I meant is, there's a certain level of understanding you may be expecting, to the point that maybe if you say do this, and expect it to happen according to expectations. So my point was, we do have an idea of what you're doing.
Is there a group that has started writing software, code? Is there anyone in here who is part of a group that have started writing, that have started implementing their program? Is there anyone in here who started doing that? Come on, what is wrong with you people? Could you? So none of you have started writing code of any sorts, right?
Yes, sir. Us, we haven't yet started writing coding.
Okay. Royd's team, have you started writing any software or something? Have you started programming or something?
Not really.
Okay. I see. Sharon?
Not yet, sir.
Okay. Mwamba, have you started doing anything with Charles? I see Charles is in the room as well.
No, sir, we haven't yet started coding.
Great, good. Because the single biggest mistake you can make at this point in time is to start writing code, right? You only start writing software once you have a comprehensive list of requirements. This is what we're doing right now, right? We want to make sure that we get to a stage where we have, oh my goodness, where we have the requirements, right? We want to get to this stage here. We can only start writing software once we are done with requirements elicitation and specification, which is otherwise called requirements engineering, right? So right now we are, if you look at what we're doing from the perspective of the journey we've started, we are here. Sorry, we are here, right? The next step is we get to look at, we study so-called unified modeling language, where we study the different types of designs that are supposed to be used in conjunction with the software specification document to feed into the implementation. So you only start implementing once you're done with the design stage. And I mentioned that those of you that, whose proposals made mention of the fact that you're going to use agile techniques and whatnot, I recommended that we hold on to that because it would be a lot easier for you to understand what we're doing if you assume that the project you're working towards is going to make use of the traditional software development model, otherwise the waterfall model, right? So you can only proceed to the next stage once you complete the previous stage. The other reason, right, and I hope you've been thinking about this, the other reason why you want to formalize this process, by the way, the end result of the requirements engineering process is a so-called software requirement specification document. The reason why you need a software specification document is that there are instances where you might want to subcontract the services of an external entity, a third party. Let's say you have this very small software development firm and you realize that you don't know how to interact with payment systems. Let's say you want to integrate your, this is hypothetical, you want to integrate your application with mobile money or, with Airtel money or MTN money, but you don't have the expertise. The thing that you do when you don't have expertise is you subcontract that particular task. So you hire a third-party company, which obviously has expertise to do that, and then they'll be able to implement that particular component of your software. Now, it becomes a lot easier for this third-party company to be able to write functionality of your software that you want if they have access to that formal document, the software specification document. And what you will realize in lecture series number 6, which we start today, is that there's a certain well, at least a recommended way of writing the software specification document. There are standards. So for instance, the standard which we are going to follow, not exactly as it appears, but we're going to pull out some aspects of this particular standard, right? So we derive a template. These standards will specify exactly how your document should be structured, right? Different chapters that you have, different ways of actually representing, if I can go to 21, different ways of representing requirements, right? So you soon see that you can represent your functional requirements by mode, requirements by use classes, right? User classes. So if you have different potential users of your system, so you organize your requirements that way. You can also organize them by object. You can organize them by feature, and incidentally, the approach we're taking in our template that we have adopted for ICT 3020 is organizing the requirements by feature, right? So from the features, you're able to derive like a specific functional and non-functional requirements, right? The template that we're going to be using is this, right? You notice it, and there's a discussion lecture series number 6 where we discuss each of these different sections and subsections and subsections so that we understand exactly what sort of content is supposed to go in here. But the template that's going to be shared with you, right? It's going to be, it is available in Moodle actually, has placeholders here that specify exactly what sort of text is supposed to go here, right? So the end result is supposed to be a document that has all these different details. And it is from here that you combine, obviously this document, by the way, also has, it incorporates certain design artifacts, like for instance, use case diagrams, right? And I guess to a certain extent, maybe interaction diagrams also. So, but all of these different models will be extracted from the system design phase, incorporated into here so that whoever is going to read this document will be able to understand exactly what it is you're building. And it makes sense, right? Because remember we mentioned that when you're dealing with sophisticated software, complex software, you do not have the same group of individuals who are going to collect requirements, come up with this formal specification document, come up with design artifacts, and implement the software, test the software. No, you have separate groups of individuals. The software development companies will normally have people that perform dedicated tasks. So there are people that are hired to go and collect requirements and come up with a formal document, people that come up with the design artifacts, people that will actually write the code, right? And you realize that if you have a different person who's going to be writing the code, you want to make sure that you use an internationally recognized standard or something, or some notation that you've adopted as an organization that everybody else is able to understand in that particular organization. But you're better off using a well-established international standard because people come and go. In the event that somebody is fired and you hire a new person, that new person, if he's been trained to read this sort of document, it will be a lot easier for them to make sense out of what exactly it is you're building. This is the whole essence of what we're doing here. Very, very soon we start we are going to start design, and then we touch on aspects to do with implementation, really. Although we don't focus on implementation, our major focus is just going to be on things like version control, for instance. You know, when we're working in groups, how do you get to collaborate with other people, right? So that's the only part we're going to touch under implementation here. But we are definitely going to spend a considerable amount of time on validation and testing, because we want to be able to make sure, to confirm that what we've built conforms to what the user specified here. The last thing you want is you build something, and then the user comes back to you and tells you, we did not ask for this. This thing doesn't do what we expect it to do, right? It's totally useless. So I hope that kind of makes sense. Unless if there are any questions, we'll proceed to lecture series number 6. So today, unless if there are any concerns or comments or something. Okay. So, yes, sir.
On the issue of integration, I wanted to find out, I just took note of something, like when you make a payment, when you are making a payment for the tuition fees,
Yes.
Immediately the system, like the system for UNZA, you pay to the bank, and the system to the university automatically updated itself. So I wanted to know, is it something to do with an integration whereby the university and the bank agreed and there was some kind of integration which happened, or what?
Yes, so that's exactly how it works. So you could view the payment system at Zanaco. Now I don't know how the integration actually takes place here. So just take what I'm saying with a bit of grain of salt here. So it might just be the case that, in fact, I don't know if I'm wrong, correct me if I'm wrong, but I'm sure UNZA specified specific banks and accounts where you're supposed to deposit money, right? Yes?
Yes. Yes.
Also, they tell you to say when you're depositing money, I don't know how you specify, I guess maybe the reference to the comment, I don't know if it's a computer number or something. There should be something to that effect, right?
Yeah.
Yeah.
Computer number.
Right. So obviously, UNZA has come up with some sort of arrangement with Zanaco or whatever other bank they have a working relationship with. And they obviously have access to those details. So they've interfaced their SIS, their platform with these different banks, so that every time there's a transaction that occurs, I'm sure there's some sort of, I don't know, some notification that comes from the third party in this case. It could be Zanaco or something, or Stanbic, to signal the fact that this person has paid. Now, in the past, right, when I worked for, I'm not sure if it's instantaneous for UNZA, but when I worked for Airtel, it was a very funny arrangement. There were batch jobs that would run, right? So certain things wouldn't necessarily reflect right there and then. You'd only be able to see a change, maybe you see a change 24 hours later or something. And in fact, if you think about it, just let's pause UNZA for now. If you're sending money, let's say from Stanbic to Zanaco, in the past, I don't know if this is the case, they'll tell you to say the money will only reflect after 24 hours, give you 24 hours. There's likely a batch job that runs, right? So the Zanaco system, some funny system that they have, will process all these, is it amounts that are supposed to be, is it credited? onto an account in a different bank, and then the system on the other side will be able to effect that particular change. Now, I'm not sure if things are still done that way manually. It's entirely possible that it's been automated somehow. But I think BOS, the central bank, has some clearing house or something where this integration kind of like takes place. So back to the UNZA example, yes, the UNZA SIS system most likely makes use of, I hope so, a web service associated with Zanaco, right? So there's hopefully an API. Option one is there could be an API that the SIS interfaces with, and every time there's a change, a corresponding change on SIS takes place. So if you make a payment at Zanaco, then you'll be able to see that the payment reflects in SIS. Option two is it could be a manual process, right? Where maybe Zanaco just send through like a CSV file, an XML file to say these are the transactions that kind of like took place. So that particular output file will be used as input by SIS, and then you see the respective changes. I hope that answers your question. But this touches on to system interface analysis. And this is what you're going to be doing. The vast majority of you are building these small little software packages that are supposed to, or that are meant to interface external services, Google Calendar, Moodle, Google Groups, right? So for you to be able to, and we mentioned this last week, for you to be able to understand exactly how you're going to process whatever input is going to be coming your way from the third-party application, the web service, you need to understand exactly how to interact with that web service. Remember the request response cycle I mentioned about, the client-server architecture, right? This is how the world works now. If you think about software, right? You go to Lusaka Times. Oh, and I have this because I'm teaching a data mining course in the computer science department. But you go to Lusaka Times, and I hope it's there. What you notice is integration with Facebook. You go to Zambian Watchdog, there's integration with Facebook, right? I hope it's there. I know in Zambian Watchdog it is there. This is a horrible example. It's not there. It is there. This is no, it's not. Well, implicitly it is there actually. A different type of integration. I'll pause for now. But if you go to Zambian Watchdog, I know Zambian Watchdog has this feature, right? If you go to Rwanda says relationship with Zambia and whatnot, I didn't read this. You will notice that here, you see comments that are native to the WordPress site that Zambian Watchdog uses. And then you can also view comments coming in from Facebook. Now the integration is a bit if, and in fact, I can comment using my Facebook profile. If you notice here, if I comment, I can also say post to Facebook once I comment, right? This is possible because of third-party integration. Even though you can't see the comment streams for the Facebook page for Lusaka Times here, but there's integration by way of Gravatar. I don't know if people have heard of the Gravatar service. Does anybody use Gravatar here? Anyone ever heard of Gravatar? What do you do online, right? So Gravatar is a service that allows you to specify things like profile pictures. And then what you do is you interface them with different third-party applications. So what I do myself, and I'll just log in with Gravatar. What I do myself is my email address, my personal email address is linked to a specific Gravatar profile picture. Every time I make a comment using that email address, that profile picture is the one that appears, right? So if I log in here, and I could have easily logged on, I will easily log in with Google here. This is another third-party integration. So I'm authenticating using a Google account. I can also log in natively here, right? Yet another way of integrating third-party application. So once I log in here, you notice that I have a number of avatars that I use, right? Currently, the active one is this. But the moment I choose this as a primary one, people that receive emails from Lighton, for instance, from my personal email account, will no longer see this profile picture here, but they will see whatever I decide to choose amongst these. And what I do is, and this is just personal preferences, whenever I pick a new avatar for myself, I cascade it throughout all the different email addresses that I use, right? So email addresses from my alma mater, my personal email address, another email address from my alma mater, and UNZA should be here as well. I should have added UNZA. Oh, UNZA is here as well, right? So you notice that I use a consistent avatar, which is why every time you receive an email from Lighton, hopefully you see this, right? Integration, right? This is all possible because of third-party integration, right? And you only be able to do this in your respective projects once you go through system interface analysis. I do hope you have started going through the system interface analysis process, where you've now identified specific endpoints that you're going to be working with in your respective projects, because that's all part of the illustration process, right? And I gave away the illustration techniques, the mandatory illustration techniques that you're going to have to undertake. Document analysis. If you're working with a third-party application, if you're going to be interacting with an application programming interface, you're going to have to read the documentation. If you're going to integrate with a third-party application or an application programming interface, you're going to have to conduct the system interface analysis so that you know which particular endpoints you're going to be working with. I'll give you an example, Moodle API. A typical web service will typically have a broad spectrum of endpoints, so-called endpoints. So the specific resource paths that you're going to be sending a request to so that you get the response that you want. There are a number of them. If you look at Moodle, right? There's a page API, there's all sorts of APIs, right? Some of them are admin-specific APIs. So what you have to do as part of document analysis is, if you're working with Moodle, identify which particular endpoint you're going to be interacting with as a group. Once you identify that particular endpoint, you start playing around with Postman, right? So that you know exactly how you're going to write software that is going to interact with that specific endpoint. I'm saying this again because this you will have to do, right? Okay, so back to why we are here. I'm just going to pause here to find out if people are still there. Okay, so back to why we are here. So we start our discussion of requirements. Yes, sir.
Yeah, the response to my question. I just wanted some more clarification. You mentioned something like to do with third party.
Yes.
Now, for the same example I gave. So who takes responsibility when it comes to a third party thing? Because there is UNZA involved and Zanako. So who takes responsibility of the software? Let's say, for example, there's a mess in the software and it shows like someone has paid and yet they haven't paid. So who is monitoring the software? Is it the bank or is it UNZA?
Well, good question. Excellent question. There are two different pieces of software here, right? And because there are two different pieces of software, the custodians of this software are two separate entities. So there's a piece of software that is managed by the UNZA, it sits on the UNZA servers, and then there's a piece of software that is managed by Zanako. When something goes wrong, and the client reports that something goes wrong, of course, the two parties will work together to identify where the problem is, right? And then once you identify where the problem is coming from, it's fixed. I hope I can, I want to showcase something happened in my case. Thanks for asking this question. Not too long ago, I purchased power, right? I normally purchase power, I don't know if you can see this. I normally purchase power using my bank account, right? And so what happened was that, and what I'm going to do is, I don't know if you can see this email heading here, Zanako, Zambia. I want to showcase something. I wonder if I can, but I don't want to show my account. So what I'm going to do is I'm just going to briefly stop sharing so that I just copy the email and then remove sensitive information from there. Not that it matters anyways, but so that it's important that you ask these questions, because these days people don't write pieces of software that that work in isolation, right? You always write a piece of software that I don't think this is going to be there, but you always write a piece of software. 1, 2, 3, 4, 5. You always write a piece of software that's going to interact with other third-party applications. So something really interesting happened, right? I purchased power, and what happened was that the bank, right, Zanaco, when I purchased power using my bank makes money, right, by charging me a 15-way charge, right, service charge. So every time I purchase power, Zesco power, via my Stanbic account, I'm charged 15-way, right? And so what I noticed when I was doing my audit in my personal accounts is that there was a duplicate charge, 15-way charge. I was charged twice for this 15-way. And so what I did was I wrote to them to find out why I was charged 15-way twice, right? And so this person, and there's a whole thread here, an email thread. And so this person responds to me, a customer service consultant, I suppose, saying that the 15-way is a charge for electricity. And we there's a back and forth where I explained to her but the 15-way was charged twice. Why was it charged twice? And they discovered that when I purchased power, it was a Saturday or Sunday or something, there was a reversal that came through from my bank because the transaction failed. When I purchased power via Stanbic, there's a Stanbic application that is interfaced with Zesco to tell the Zesco application to say, this person has bought units. We can confirm that this person is our client. He has bought units worth, let's say, 500 kwacha or something. Once that acknowledgement is sent through to the other party will send me the code, the units for the code, right? So Zesco, once Zesco receives information to say, acknowledgement from Stanbic Bank, in this case, to say the deduction is successful, then they will send me the unit that I need to punch into the Zesco interface, customer interface unit or something, right? Now, what happened in this case was that I never got the code, right? And so when I complained the first time, they reversed the charge. When they reversed the charge, they did not give me back my 15-way charge. So as a result, there was 2 15-way charges. And so after back and forth, Stanbic realized that the issue was on their part. And so they reversed the 15-way charge. So to answer your question, the responsibility depends on where exactly the problem occurs. In a pipeline or a workflow where you have multiple stakeholders involved, the first thing you do is you troubleshoot to identify where the problem originates from. Once you identify where the problem is coming from, the party responsible is going to fix that problem, and then hopefully the kumbaya or something. I hope that answers your question. These are brilliant questions you're asking. We are learning here. Yeah. Okay. Any other thoughts about system interface integration? It's interesting. So you are going to have to do this. You better ask, right? Okay. So today we start lecture series number 6, which is requirement specification. We're still dealing with requirements engineering, but this is the last phase, requirement specification. And what we're going to do is we're going to go through these different ideas here or concepts. So we're going to first of all contextualize this whole notion of requirement specification, and really just trying to rub it in here that the key output for requirement specification, so far as we're concerned here, is the SRS document, the software requirement specification document, right? So we want this formal document at the end of the day, this formal document that is going to feed into the implementation together with the design artifacts, right? So essentially what we're learning here is how to formally write the things that feed into the software requirement specification document. Something else we're going to do is just have a brief discussion of the various types of requirement specification notations that I use. What you will discover is that once we start passing through the requirement specification document template that we're using, that we've adopted, there's a certain convention that we will be using to represent certain parts of the document. Like for instance, if you're incorporating so-called use cases or use case diagrams, they have to be represented in a certain way, right? Use cases, for instance, sometimes will be represented with preconditions and postconditions and all those different things. You might lump in so-called use case diagrams or sticky figures with bounding box. And then finally, I'm saying finally here because I'm tempted to, I think we should just have a separate lecture series number 7, where we discuss requirements validation and change, but maybe we can slot it into here. But we're supposed to just have a brief walkthrough to understand exactly what sort of aspects are supposed to go into that formal document we're calling the SRS document. And we'll go through, we'll explain the different sections so that we understand what that's all about. And then we'll look at validation and change, essentially. Okay, so we'll start with just brief overview of so-called requirement specification, right? A reminder that specification is part of this broader idea of phase associated with software development lifecycle we are calling requirements engineering, right? The only difference with this sub-stage or sub-phase is that what you're interested in doing is generating, using the formal using the requirements you've collected, you've elicited, you generate this formal requirements document, right? But also this software specification that you come up with is supposed to feed into the verification and validation stage, right? Because what you use as a basis to verify that what has been done is actually correct is actually the requirements, user requirements in part, right? So you notice that we are here, just try and contextualize things. The assumption we're making is stakeholders have been identified, user requirements have been elicited. What we want to do now is to convert the elicited user requirements or to represent them formally in great depth so that the people that are implementing the software are able to understand exactly what we need to do. But also, this thing is supposed to serve as some sort of contract with the customers or the clients, right? You use that as a basis to verify whether what the client specified has actually been done. Feel free to interrupt me if you need to interrupt me. So the software specification process here, textbook definition, is nothing more than the process that you go through to formally write down the user requirements and the system requirements. And we, in the previous lecture series, we highlighted the difference between user requirements and system requirements. There's different ways of looking at user requirements and system requirements. You can look at them from the perspective of who exactly is going to consume those requirements. You know that the user requirements are nothing more than high-level representations, and so usually it's the clients of the software, right? The end users, the consumers. System requirements are detailed interactions of end users and the system, for instance. And these are things that would typically be useful to people that are writing the piece of software, people that are programming, designing the software, right? Which is what we're saying, user requirements have to be understood by the end users, but system requirements are more detailed. These are more technical in nature, actually. You give a user requirement to a student who is going to interact with the makeup request application, and they'll be able to understand what you're doing. But you give them a list of detailed system requirements, and they will not be able to make sense out of what's happening. The person who's going to will be able to make sense out of that is a person who has been trained to read system requirements. They'll think you're mad when they see these things, for instance. When they see these things, they'll be surprised as to what this is, right? But anyway. Right, so because the specification includes details of what the user expects and details of how the system is going to behave, as potential end users are interacting with it, you need to make sure that these details are as complete as possible, right, in the document itself. Again, just to rub it in here that the output of the requirement specification phase here is the validation process that you go through to confirm that what you've come up with actually includes everything that the client expects, and more importantly, the formal contract, the formal document, where all these things are going to be clearly laid out in black and white. right? So at the end of it, you come up with a document that is structured as follows here. So again, I mean, there's usually this misconception as to what the relationship between requirements and design is here. And sometimes there's a thin line. You sometimes incorporate design artifacts into this software requirements specification document. That's fine, right? But ideally, what the requirements do is they state what the system is going to do, and the design will describe how that happens, right? Two different things. The end goal is the same. There's the what the system is doing and how it's going to accomplish that. And you see this once we start looking at the different UML artifacts like activity diagrams and interaction diagrams and things like, I don't think we're going to look at state machines, but maybe class diagrams, deployment diagrams. You notice that all of these different design artifacts will spell out the how the system does that, how the system is going to be deployed, how the different elements of the system are going to interact with each other, right? I just mentioned this here, but the requirements and design really intertwined, right? You will find design artifacts in the software requirements specification document for you to be able to explain the requirements associated with the system that you're describing. You might want to complement that with design artifacts. In our case, the one thing that we are not going to do away with are the use case diagrams, right? So these sticky figures here. These are all done as part of the design process. But we will need to feed them into this template that we've adopted for ICT 3020. And it's not uncommon actually. Most of these internationally recognized templates that are available out there, and there's a lot of them out there, will typically require that you include a use case diagram. All right. So a system interoperate with other systems that will be used to generate these design requirements, for instance. Right? So a few guidelines here when writing requirements, right? These are just guidelines. It's not like they're set in stone, but these are things that will ensure that you come up with an SRS document that will be easy to synthesize by anyone who reads it, anyone who's been trained in the art of synthesizing requirements, right? From a formal requirements document should be able to understand exactly what it is you're trying to put across if you follow through with these guidelines. Number one, you want to make sure that you come up with a formalized standard, or better yet, use a pre-existing standard, right? That will be used as a basis to specify all the different types of requirements associated with the system you're developing. So this includes both the functional requirements and the non-functional requirements. You also want to make sure that you use language consistently, right? It turns out that certain words mean certain things, right? So words like shall or will, for instance, or should, right? So you want to be very careful how you use these words, right? In the case of shall, for instance, you use shall for mandatory requirements. The system shall ensure that a user logs in before they start interacting with the system. Should is a desirable requirement, so that it's not set in stone. The system should optionally ensure that a user is able to log in using single sign-on, using popular single sign-on features like Google single sign-on, for instance. I think you've seen this feature, or Facebook, or signing in using Facebook or something. It's not a hard requirement, but it is possible. So should, shall, right? You can also use, or you should also use text highlighting to identify key parts of the requirement, right? So bolding and use bold text, or maybe text in italics, for instance. You want to avoid using technical jargon. Why? Because you are not just writing this requirement document, this SRS document for potential end users, for the people that are going to be developing this piece of software. You're also writing it for your clients, the customers, the people that approached you to say, we want you to develop this piece of software. And so the language that you're using, especially when you're describing user requirements, you want to make sure that you avoid computer jargon so that the customers, your clients, are able to understand your requirements. Always include a bit of description and explanation, outlining exactly why a requirement is necessary, right? Why it has to be included there. And so with that being said, you notice that it's imperative that you use some sort of natural language, right? When you're specifying these requirements. So language like English, for instance, or if you're Chinese, that would be nice. The people that are studying Chinese, maybe they'll write the requirements document in Chinese. That won't work because your clients are either light on or the students or something, or the right? They look at you strange, they won't understand Chinese. But requirements are normally written in a natural language, right? Complemented with visuals. So visual representations of the requirements themselves. So this could be, the visual representations could be, visualizations could be diagrams, block diagrams, for instance, or specific types of diagrams like use case diagrams, interaction diagrams, or class diagrams. But you can also use tables, right? Tables are quite common when you're describing your use cases, when you're coming up with the use case scenarios, for instance. It turns out that the description is usually a lot easier when you use diagrams. Let me just show you something quickly. Are you still there, by the way? Just, I hope I haven't lost connection. Are you still there?
Over here.
Okay. So an example of a use case template is something that looks, and this will be shared with you again once you get to the stage. It looks something similar to this, right? I hope there's no tables. Okay. Ah, there we go. So this is like a nice way of representing a use case, right? Using a table. Right, where you specify the ID of the use case because you need to reference this somewhere in the document, obviously. And this is important because during implementation and during design, you want to be able to refer to the use cases by an ID. So you go and approach, a developer comes to you as a person, as a business analyst that assembled this document and come to you and say, I needed help with use case ID 115, for instance, right? Instead of referring to it by name, IDs are used, unique identifiers. Details to do with who exactly created that use case, when it was created, when last it was updated, who updated, when last it was updated, who updated it last. And you notice that some of these things are beginning to make sense, hopefully, right? This idea of when it was created and who updated it and when it was updated. It makes sense that you update this because this whole SDLC, right? The software development lifecycle it's cyclic in nature, right? You loop, you end up looping. You do something, you go and approach your clients, and then maybe they'll tell you, actually what we had in mind for that particular requirement is not what you've implemented. What do? You go back to your SRS document, you modify it. When you modify it, you specify details of who modified it and when, right? And usually there's this idea of versioning these things, right? So you tend to version the document so that you can easily go back and refer to another version of the document. Various ways of versioning documents, yes, project management task actually. So yeah, visual representation, quite common, but also some people normally represent use cases by just using simple sections, right? Sections and subsections here. It turns out that in my case, I mean, I tend to gravitate more towards tables, right? Because when you provide someone, a developer, with something like this, they know exactly what to do, right? It's a lot easier to synthesize information from here, as far as the developer is concerned, than them going through sections, subsections, and subsections of that particular use case to try and understand what exactly you need, right? And you see this in so many different instances. I'm just gonna refer to, I hope I'll be able to, there's a project that I'm familiar with because I didn't really actively actively participate in the, oh, this thing is hanging. I didn't actively participate in the my goodness. Sorry, my machine is hanging. I didn't actively participate in the project per se, but I played a role somehow, right? I was interviewed, when they were collecting requirements, right? I participated in that process. So I developed an interest because it happens to be an area where an area that I'm familiar with. So what I'm gonna do here is, I'm going to do something unorthodox here. And because I know my machine is acting up, when it starts acting up, I have to close. Remember our discussion of memory in 1110 here. This is what's happening here. But I want to look at a project called, was that in 2017, I hope. It appears it wasn't funded. I know, and I want to use this as an example because those guys, it was classic software engineering here. It was agile actually, but they have some really properly documented. Wow, I thought it was it 2015? Oh, time flies. It was actually 2015. So, wow. So if I go to downloads, I guess. And I go to, okay. I'm just going to open both of these just to, I can't remember if it was Daryl or Feedman or something. I don't know. I'm forgetting these people, right? I can't remember if it was Daryl or Craig. But perfect. So I hope this part of the thing is going to have, which is a bit use cases. If you look at the use cases that they have here, right, for the different features, if I open them up, I hope there will be tables here, tables and certain use case diagrams. Tables, right? You see this? This is what I mean here. Specifics of what is happening, right? This is a lot easier to make sense out of rather than textual representation. Right, I do believe I probably do have a use case diagram. I'd be surprised if I didn't. Maybe I didn't in my thesis, I guess. I don't know. Let me just check. Use case. Maybe it was in the. I think it was. It shouldn't be in the. I would have been surprised if I used it here, right? It should have been in the. Yeah, it should be in the actual design documents. I before building the tools here, describing this document anyway. But this is the idea, right? Visuals. So tables are a nice way of representing use cases, right? And we understand exactly how this is done during our discussion of use cases or use case scenarios anyway. Right. Okay, so you want to make sure that you use visual representations to supplement, so diagrams and visuals, right? Tables, diagrams to complement the actual requirements that are written in natural language. And the idea for using natural language is more expressive and intuitive to understand, right? It's something that your potential users of the system will be able to synthesize and understand, so that they're able to confirm whether or not the requirements that you have in that document actually correspond to what they want. But it turns out that the so-called natural language specification approach has a downside to it, right? Usually there's a bit of lack of clarity, right? And so it makes it difficult for you to read the document. So the idea here is that if you look at the template we're going to be using, this template will have natural language specification. If you look at this, 3, right? Use case definition, use case guidance, use case identification. So you have your use case definition, right? And then you have your actors and your triggers and whatnot. If you just rely on this natural language specification here, what we're saying is that it can be confusing, it's difficult to read, right? Which is why we are saying you have to complement this with something similar to, I don't know where that is, but something similar to this here, right? A table that's much easier to understand, it's more expressive. It can be confusing also, right? When you just rely on the natural language specification, you tend to confuse people that are going to be reading that document. You tend to be confused as to which of the requirements are actually functional and non-functional requirements. So that then obviously several different requirements can be expressed together, obviously. Right? All right. So the question then is, now that we understand what requirement specification is all about, the question is what sort of notations do we use to derive or to write this requirement specification? It turns out there's different types of notations, and this is what we're going to go through. Granted, I just want to put it out there up front that the SRS document that we're going to be using, we use a combination of, it will have some aspects of some of these notations that we're going to go through. So for instance, we incorporate use cases in there. We'll use tables, right? And we'll take a more structured approach. But these are different notations that you tend to use either in isolation or in combination with each other as you are deriving the SRS document. Are there any questions, by the way, with regards to writing requirements and okay, just pause here. I don't know if people are still around. I've been a bit reluctant to figure out how to tell. I'm sure there's bound to be a software application that you can use to check if people are online or not, right, as you're presenting. Can I have someone just say something here? Moses, are you still there? Okay. No, we have to be formal, right? No one will take you seriously when you do that. I certainly wouldn't actually, right? You want to learn how to be formal here, right? Formal cascades everywhere. When, yes, Nyanja, Lusaka slang Nyanja is natural language, but what we're talking about here is English, right? Anyways, nice to people. But anyway, so we're going to look at these different notations, right, in succession. But just put it out there that the different notations are there to achieve different types of goals. Like for instance, the normal natural language here will normally be represented in your SRS document by enumeration, right? So enumerate the sentences. And typically, as far as the requirements section is concerned, there's usually a sentence that is used to represent a requirement. The structured natural language approach will use a natural language, obviously, using a standardized template. So this is actually a classic example of what, sorry, the kids making noise outside. I'm sorry about that. You know, it's when you do decide to have kids in the future, if you're one of those people who's going to decide to have kids, you must teach them to do the right thing. I live in this place where there are a lot of unruly people, right? These kids. And the problem is that the custodians, they're not doing their job, right? To nurture them, make sure that they grow up as respectful human beings, respect other people's boundaries. Very sad. It's irritating sometimes. And actually, I was thinking the other time, I don't know if you guys have heard, right? There was a lady who was arrested, Zambian woman arrested, Zambian woman. I don't know if you heard this story. I guess we'll have to stop now. Zambian woman arrested for, is it stoning child or something? Did you hear about this story, guys? Ah, there we go. And I sat there and I was thinking, I'm sure
Yes,
this lady.
I heard about the story.
I sat there and I was thinking, I think this lady probably felt the way I feel, but of course I don't go that far, right? Occasionally, I mean, there are kids, I know, but I'll be stern. I will speak to them, but they don't listen. They think it's a game, right? It's quite sad. But anyways, I'm sorry about that. I got distracted there. I'm going to suggest that we pause and we will continue. We reboot here. We'll continue this conversation. Is it Monday or something? I don't know when we're meeting. Just check. I think we're meeting.
Yes, it is Monday.
Yeah, so we're going to continue this conversation on Monday, where we'll just, I'm sure we'll be able to wrap up. At least we'll go as far as start describing the SRS document, you're looking at the different components of the SRS document. So I'll see you on Monday at 18. Also, I wanted to mention that there's an assignment. We were supposed to be made available today, this week at least, but it's going to be made available on Monday. It's meant to help you start crafting or putting together these instruments that you're going to use to elicit the requirements, right? So if you're going to be using an interview, we want to force you to come up with an interview guide. If you're going to be using a questionnaire, we want you to come up with a questionnaire and specify exactly how you're going to administer that questionnaire, how you're going to conduct that interview, whether it's Google Meet or something. Sorry for the interruption. Sad place. Life is sad sometimes. No wonder there's people like this woman, but this was extreme. They jailed her, right? It's quite sad. She used to work for MTN. 5 years. Wow. I'm sure she had a bright future ahead of her. But I don't think that female prisons are as harsh as the male prisons in Zambia. You don't want to go there. Guys, I'll see you when you see me, which is Monday. I will share the video and the lecture slides as soon as the rendering is complete. Thank you so much and take care. Thank you. Bye.
Bye. Thanks too.
Hawkins. Hawkins here.